Welcome to the Science of Tree Felling series. In today's video, we're going to talk about mechanical advantage. In the previous videos, when we were talking about leans, we finished off with what happens when you have a back-leaning tree. As gravity will tell us, when you release a tree from the stump and there's no longer anything holding on to it, trees will always fall in the direction of the lean as in relation to gravity. So if a tree has a back lean, which means that it's leaning opposite to the direction of our target, we need to do something to get that tree up over the center of the stump and at least just a little bit, 1 inch over its center, and gravity will bring it down to the ground in the direction of our target. But we have to get it there. So how do we get it there? One of the easiest ways to get it there, especially if you're an arborist and you can carry a fair amount of gear near and to the tree, is with a rope or a chain or a cable or some way to actually attach to the tree and pull it in the direction of the target. Most arborists are going to be equipped with this, and it's fairly simple to perform and do and add mechanical advantage in a bunch of different ways, and we can get that tree to come up and crank over once all of our cutting is done and go in the direction of our target. Another way that we can perform this operation to get it to come up and over is to push the tree. Now, this is the most dangerous way to get trees to go towards our target and oppose it to gravity. If somebody is cutting at the stump, or even if it's the individual who was formerly cutting at the stump, attempts to push the tree, we can run into some complicating factors. We see a lot of accidents in our industry as a function of people putting equipment on the backside of the tree, pushing with that equipment, and then the tree hinge, which attaches to the base of the tree, failing and causing that tree to come over and on top of the operator of that piece of equipment. Standing directly behind a tree or using a piece of equipment directly behind the tree is a very dangerous place to be. And we'll talk about retreat paths in a future video, but when this tree starts moving, the last place I want to be is in front of the tree, and the second last place that I want to be is directly behind the tree. So that's a consideration we need to make. If we're going to push the tree, I don't advise it. However, what we can do is use the function of an inclined plane in the form of a wedge to be able to add mechanical advantage to pick up and push that tree up over center so that we can get it to go towards our target. Now, once I had figured out the amount of mechanical advantage I can retrieve out of one wedge, it really solidified in my mind the power of this tool and the simplicity of it in use for tree felling. So why is this to our benefit? Because we need very few tools. I need an axe of some kind with a large butt on the axe head. The larger and flatter that butt is, the easier it's going to be to strike that wedge. Wedges should be in the form of plastic or some other material that is easily cut and safely cut by the chain of a chainsaw. The reason being, at some point in time, and you can probably see here in this video, it's possible that your chain is going to interact with a wedge. Just based on the dynamics of the tree, it's a likely thing to happen at some point in time in your career. And when that chain interacts with that wedge, if it's plastic, no harm, no foul. Plastic wedges are also fairly inexpensive. But if it's made out of metal or some other material that could damage the chain and or damage you if it's struck, that's going to be a situation you don't want to find yourself in. So make sure that you have a hardened plastic wedge. These are my preferred, and they come in all different sizes, shapes, flavors. I prefer ones with little tabs on them. They're little progress captures. So if I got a tree species with a hard back lean, it'll decrease the likelihood of this wedge slipping out as I'm trying to drive it forward. But let's talk about how much mechanical advantage we can impart with the simplicity of just one wedge. And we'll do this through a little thought experiment and an experiment you can do at home if you wish. You can do this experiment by finding any object, a 2x4 or a 6x6, anything, and cutting it square. So once you have a square object, make a few of those. Once you have a few perfectly square objects, you can find a small string and with a push pin attach it to the frontmost corner of that object. And attach a weight to that string, a washer or a nut or a bolt or something that's going to add a little bit of weight to it. Now have your wedge handy and measure the shoulder of that wedge. How much shoulder does that wedge have? Measure an inch or measure 1.25 inches, whatever your shoulder is. Now, we're going to take that square object and you're going to put it on a flat level surface and you're going to get a tape measure out as you see here. Put that tape measure against the base of that square object and push the wedge into the opposite corner. And what you're going to notice is proportionally, as you push that wedge into the back corner of that square, if you have one square, the lift that's provided from the back corner of that square is proportionate to the motion forward from the front corner of that square. Now here's where it becomes powerful. Put two squares on top of each other. Do the same experiment. Push this wedge into the back corner or opposite of your string and weight and measure how much that moves forward. If I have a wedge with a 1-inch shoulder and I can push that shoulder all the way to the back corner of that square, I will raise the back corner up 1 inch. If I have one square, it pushes the front of that square forward 1 inch. If I stack two squares on top of each other and I put that same 1 inch on the back corner, the front corner of two squares stacked on top of each other then moves that front corner 2 inches forward. We're going to do that again a third time. I'm going to stack 3 squares on top of each other and I'm going to put 1 inch in the back side of that bottom square. And then I'm going to observe and measure at the very top of that third square, that topmost section, pointed down in relation to the base of that first square is now 3 inches in front of where it otherwise was. And this is a concept that we call the segmentation of trees. So instead of thinking of trees as tall poles, now we're thinking of trees as a series of squares stacked on top of each other. And this is going to help frame our mind to how much power we can get out of one wedge. So if I'm in the woods and I have a back-leaning tree, and the tree, I'm able to calculate my lean, and if you don't know how to do this and haven't watched the previous video, do watch my video on leans. Standing 90 degrees from the direction of our target, I decide and calculate how much back lean there is by framing my target, and in relation to the stump, I look where my fingers are pointed or where the plumb line is pointed in relation to the stump, and I calculate 24 inches of back lean, 2 feet of back lean. That's a fair amount of back lean. That means if I cut the tree clean off the stump, that tree is going to fall over backwards and be aimed towards where I plan on going when the tree is released. That's not a safe place to be. So I need to make sure and calculate, and this is not a guess, this is a scientific calculation of how much mechanical advantage I can achieve based on the tools that I have. So I know some information already. I know that the tree that I'm felling has 24 inches or 2 feet of back lean, and I need to overcome that. If I have one 1-inch wedge and my tree is 12 inches in diameter, and again, in previous videos, we talked about how to measure the tree's diameter. We measure the tree's diameter at 12 inches, and we can also measure the height of the tree using that similar triangle theorem again in the previous video. Watch that if you're unfamiliar with the concept, but we know the exact height of the tree as well. So now we can picture and frame that tree as a series of squares stacked on top of each other. And I call this forestry math just because some rounding error is going to be acceptable, and I'll tell you why at the very end and how I take care of that fudge factor. So what I'm going to do then is I'm going to calculate if my tree diameter is 12 inches wide. To make a square, I can just make 12 inches wide by 12 inches tall. That's easy math. That's 1 foot by 1 foot. I've calculated the height of the tree by using my pace and similar triangle theorem again in a previous video. And I know that that tree is 70 feet tall. I know because I measured it to be 70 feet tall. 70 feet means 70 squares of 1 foot diameter, 1 foot tall, stacked on top of each other over and over again. I just talked about how much effort and movement we can get in that situation. So if I have a 12-inch square, 12-inch diameter, or 12 inches wide by 12 inches tall, and I have 70 of them stacked on top of one another, that frames my tree in this particular felling situation. And then if I can take one single wedge and I can push this wedge into the base of that tree, and I can bury its shoulder that's 1 inch tall, I can effectively move the top of that tree 70 inches forward. 70 inches forward with one 1-inch wedge. Now, conceptually, it makes sense that the skinnier and the taller the tree is, the more mechanical advantage I can get out of a wedge. The shorter and fatter the tree is, the less mechanical advantage I'm getting per wedge. So in the scenario that I just stated, if I know that I have one wedge available to me, one wedge, one axe to drive it with, and I do my cuts, and this tree is leaning 24 inches backwards with a single wedge driven into the tree, I'm going to move that top over, up and over 70 inches. 70 inches is far greater than the 24 inches of backlean that I have to overcome. So I know, and I've calculated, and this is not a guess, it's a calculation, that with one wedge, I will easily be able to overcome 24 inches of backlean. Heck, let's say I have 4 feet of backlean. That's a lot of backlean. I have 48 inches of backlean on this tree. Again, same tree, one wedge, I can make a 4-foot back-leaning tree go up and over center and go towards my target, and all I have at my disposal is an axe and a single wedge. Now, I talked about a fudge factor earlier. In my calculations, in my forestry math, I will always say, whatever you calculate, always add one wedge. It's my one wedge extra rule. So if I calculated that I can get 70 inches of front movement and I can overcome my 2 feet of back lean, I only need one wedge according to my calculation. Now, my wedge plus one rule then dictates that I should have, before I begin my felling process, 2 wedges. And this is going to apply all around. If I have a front-leaning tree, or what I've calculated to be front-leaning, that means I need no wedges. I need then, according to my plus one wedge rule, is even on a front-leaning tree, I will not begin that fell unless I have my axe and at least one wedge available to me. Why? Because we can make mistakes, and we want to have a slight insurance policy against those mistakes. So if I have just what I need, that's good, but I won't consider it a valid plan unless I have plus one wedge. And again, remember, this is part of the planning process. This is a thought process of validity. Is the plan valid? Can I proceed? Now, if I've calculated this, this back-leaning tree, and I cannot overcome the back lean based on my calculations with a single wedge, and I only have a single wedge at my disposal, the plan is not valid. Nothing that I do with this wedge will satisfy the opposition of gravity, which means that I will fail in my attempt to fell that tree. In that case, my plan is not valid, and I should not start the saw, and I should not proceed to cut, because it will not work out well in my favor, and I need to come up with a different plan. Or I can recalculate. Maybe I need 2 wedges to make my plan valid. If I don't have 2 wedges available to me, I don't start until I go and get a second wedge. So always have what you need available to you and on your body before you start the fell. And again, this is a calculation, this is not a guess. Now, I do want to talk briefly about multiple wedge use. I usually carry about 3 wedges on me by default, and I have run into trees that have taken a bunch of wedges. Sometimes I try to wedge over trees in the opposite direction of the lean just for fun. Some extreme moments, have a picture of it I'll show here of a red pine that we drove a dozen wedges into to try to make it go against the lean. It got hung up in a canopy and we eventually ended up pushing it over. It was a really fun and neat thought experiment. But there's some limitations to this. It depends on species, it depends on size, it depends on the sawyer. A lot of different factors at play, and those things will all come in time, and I can't explain everything now. But one more concept that I can give you about using felling wedges is when you have to use more than one wedge, is some cautionary notes here. Now, because of the nature of the wedges and the inclined plane, when you have to use 2 wedges, you cannot stick them in the same kerf and drive them both in together. When you stack wedges like this and you hit one, it will cause the other one to pull out. And eventually what's going to happen is you're going to hit one and the other one is going to come rocketing back out at you. That's going to do a couple of things. It's going to cause a projectile that could hit you. That's a hazard I'm not interested in. And it's also going to allow the tree to sit back, which could potentially break the hinge and send the tree in the wrong direction. So you never want to stack wedges directly on top of each other. You have 2 options when it comes to stacking wedges then. You can stick them in perpendicular to each other and drive them in this direction, and I'll show you a photo of that. And when you do that, then the wedges get locked into a situation where they're not going to come ricocheting back out at you. And this is a safe way to add to the height that you can achieve and the lift that you can achieve by stacking these wedges together, because you add together the overall shoulder width of both wedges as opposed to the limitations of just one. The other method that I'm really a big fan of is stacking wedges by boring in on top of each other. So once I have my one wedge and I've driven it all the way in as far as I need it to go, and I've calculated that I'm going to need more than one wedge, so I'm fairly confident that with my back-leaning calculation, one wedge is not going to be able to do it. I know that I'm going to need 2. I'm going to do my normal felling plan. I'm going to start to fell the tree. I'm going to stick this wedge in. I'm going to release it. I'm going to pound this wedge until the shoulder has seated. And now I have a second wedge at my disposal. I'm going to bore using the attack corner of my chainsaw. And again, if you're not familiar with the reactive forces of a chainsaw, please watch that video. Using the attack corner, I'm going to bore in directly above this wedge. Depending on species, I'm going to give it an inch or so worth of gap, and that provides a kerf necessary to apply a second wedge. Now, make sure whatever tool that you're using, how you have to bore in and cut, whether you have to make it wider or not. My saw is set up and my wedge purchase is made that the width of my bar is actually bigger than the width, and almost exactly to the width of a wedge. Additionally, you don't want to just keep pushing into the tree and cutting unnecessarily, especially if the tree has been released. So you want to spend as little time at that stump as possible. And so you should know and mark on your saw exactly where the length of the wedge is in relation to the bar, so that you only have to bore in that far. Once you've bored in and you've pulled your saw out, you can place your second wedge and you can start pounding that in. What that's going to do is it's going to fill the kerf and it's going to break the fibers, leaving that chunk of wood as a spacer in between these 2 wedges, allowing them not to push and kick back out towards you. And then you can continue to drive the second wedge into the shoulder if necessary. And you can repeat that process over and over again, depending on species and situation. That'll come in time. But I have successfully driven many wedges stacked on top of each other into a back-leaning tree to manipulate it to go in the direction that I want. And you cannot stack them directly, so you have to manipulate them in some fashion, and bore cutting is one of my favorite ways to do that. So that's just a few things to try to overcome back-leaning trees, and adding some mechanical advantage with some simple tools that you readily have on you. And with that, keep watching the videos, and thanks for listening. Thank you for watching the Science of Tree Felling series. My hope is that you find these videos educational and that you learn to be a better, safer tree feller. If you know others who may benefit from this series, share the link, like the video, and subscribe to this channel. Keep watching for even more tree felling knowledge. See you next time.